Welcome to this explainer. Look, we're taking a comprehensive 2026 sourcing guide and totally transforming it into a step-by-step masterclass on industrial laser procurement. We're going to build out a complete, highly strategic workflow guide for buying industrial lasers in 2026 so you can navigate this incredibly high-stakes market with absolute confidence. Let's get right into it.
Okay, so here's the reality of the landscape right now. In 2026, thanks to intense market volatility, strict energy mandates, and the absolute rapid rise of Industry 4.0, buying a laser, well, it just isn't a simple add-to-cart checkout anymore. We are way past the days of standard transactions. The terrifying reality is that a bad purchase, one where you compromise on quality or maybe just choose the wrong supplier, it leads directly to literally catastrophic downtime, lost revenue, and heaps of ruined components. Procurement today is a strategic partnership, and honestly, the cost of failure is just way too high to ignore.
So, to avoid those massive pitfalls, we're going to walk through a really rigid strategic procurement journey to secure your ideal machinery. Our roadmap today: Step 1 is choose your tech. Step 2 is audit internal components. Step 3 is evaluate global clusters. And finally, Step 4 is execute the workflow.
All right, kicking things off with Step 1, choose your tech. This is your foundational decision.
We're starting at the critical fork in the road because this dictates your entire facility's capability. There is a really sharp juxtaposition here between the dominant metal-cutting power of fiber lasers and the highly versatile specific niche of CO2 lasers. Fiber lasers have obviously become the absolute dominant force in metal fabrication, right? They're your go-to for stainless steel, carbon steel, even highly reflective metals like brass. Now, CO2 operates on a completely different wavelength, literally. It's focused entirely on organic materials, and it comes with a much lower initial capital expenditure. Now, if you do go the fiber route, a completely crucial point is its photoelectric conversion efficiency, which frequently tops out over 30%. This is massive. It means a direct, highly noticeable plunge in your monthly electricity bills. Plus, because it's a solid-state design, no mirrors to constantly align, your maintenance-related downtime is kept to an absolute minimum compared to those older gas-based systems.
And check this out. Top-tier fiber sources are rated for an astonishing 100,000 hours of operation. I mean, think about that when you're looking at your facility's balance sheet. A machine running reliably for 100,000 hours is an incredibly stable asset for long-term depreciation. It really acts as a foundational pillar for your industrial manufacturing.
But hey, if you're a startup, a signage maker, or a packaging business, definitely do not count out CO2. Honestly, if your manufacturing output involves organic materials, CO2 isn't just relevant, it's practically required. It gives you a much faster break-even point and a specific edge quality, like that perfectly smooth, flame-polished edge on thick acrylic that a fiber laser simply cannot replicate without really expensive secondary processing. So if you're working with wood, leather, textiles, or specialized polymers, CO2 is for sure the way to go.
Moving right along to Step 2, audit internal components. Time to look under the hood.
Once you've nailed down your base technology, we have to shift our focus from those outward specs to the actual anatomy of the machine itself. When you issue your request for quote, you need what's basically an X-ray audit checklist to make sure the machine perfectly matches your expectations. You absolutely want a heavy-duty welded frame or a cast-iron machine bed. Why? To prevent deformation from years of high-speed, intense vibration. You need top-tier precision motion systems. Think YAC racks or Agewin rails. You also want to look for Yaskawa or Panasonic servo motors. Because let's be real, there is nothing quite as ironic as saving a few pennies on a cheap stepper motor only to scrap thousands of dollars in ruined metal later when it inevitably loses steps. Oh, and don't forget your chilling system. Overheating is the #1 killer of laser sources, so demand reliable industrial chillers like SNA or Teiyu. Finally, insist on industry-standard control software like Sipcut or Ruda, so your operators actually have online support and tutorials they can easily look up.
Okay, let's pivot to Step 3, evaluate global clusters. We're mapping out your supply chain.
We really need to look at how the geopolitical landscape of your purchase, and just geography in general, impacts component quality. Where your machine is built actually tells you a ton about the ecosystem supporting it. Take Jinan, for example. Sourcing from Jinan means you're tapping into an incredibly dense, highly cost-effective ecosystem. It's actually known as Laser City for a reason. Practically every subcomponent is available within a 50-mile radius. This incredible density drives down production costs and means that even the local logistics providers are highly specialized in creating and shipping these heavy industrial lasers safely.
Conversely, if you're really scaling up to massive industrial power, we're talking 12 to 40 kilowatts, Wuhan is where you want to look. That's where the primary source manufacturers are pushing the absolute boundaries of beam stability. Wuhan is home to major research institutions, and it serves as the ultimate technical benchmark for thick plate cutting technology. Knowing these geographic clusters really helps you zero in on the right manufacturer for your exact needs.
Now, depending on who you are as a buyer, your vetting process has to change. A one-size-fits-all approach? Yeah, that rarely works here. If you're a small buyer or an e-commerce seller, you've got to prioritize a software-first procurement strategy. You want to avoid those frustrating proprietary software locks by ensuring full compatibility with third-party software like Lightburn. You also need rapid shipping, right? So you should specifically look for suppliers with overseas warehouses to slash those shipping times from months down to mere days. And lastly, you must insist on comprehensive English language video training modules.
But what if you're a bulk buyer or a brand owner aiming to white label equipment? While your strategy pivots entirely to an OEM approach, your total focus shifts to consistency. You need to know, can the supplier offer chassis customization to match your specific brand identity? You absolutely have to verify that they are using the exact same component brands across every single batch, rather than quietly swapping out parts based on daily market pricing. And most importantly, they must provide localized safety certifications like your UL, CSA, or CE marks to legally meet your specific regional requirements.
All right, finally, we reach step 4, execute the workflow, taking it from RFQ all the way to quality control. This right here is the rigid operational protocol to actually buy the machine without getting burned. I want you to follow these exact 5 steps meticulously to mitigate your risk. Step 1, define your material specs using the 80-20 rule. What exact thickness and type of material are you going to be cutting 80% of the time? Step 2, request sample cutting. Send them your specific CAD files and demand a live video of them being cut, followed immediately by high-res photos of the edge quality. Step 3, verify the laser source. You've got to check the serial number directly with the original manufacturer so you don't accidentally end up with a refurbished unit. Step 4, audit the factory. Simply use a third-party inspection service to verify their true production capacity. And Step 5, finalize your shipping Incoterms. Whether you're using free on board or cost, insurance, and freight, you must verify exactly who pays for and who manages that incredibly treacherous last mile of deliveries straight to your facility doors.
So, as we wrap up this explainer, I really want you to take a hard look at your entire procurement workflow and ask yourself this one final question. Because in today's 2026 landscape, a supplier's transparency is just as critical as the steel you're cutting. Are you just blindly swiping a credit card for a piece of hardware, or are you actually building a foundation for the next decade of your manufacturing capability? Keep your technical literacy sharp, rely on the structured workflow, and make absolutely sure your next procurement is a true 100,000-hour partnership.